This one is almost embarrassingly simple, and that's what makes it so dangerous. MCP servers, in the way most people actually deploy them, need credentials to connect to things. And the most common setup looks like this. You create a JSON file or a .env file, you put your API key in it, your access token, maybe a username and a password, and you point the MCP server at that file. It reads the credentials on startup, authenticates to whatever service it needs, and you're up and running. The credentials are sitting in a plaintext file on the developer's machine. Now, think about what that actually means. You do not need a sophisticated attack to get those credentials. A malicious MCP server does not need to exploit a vulnerability or find a zero-day. It just reads the config file it was handed. That's its normal operation. The architecture gives credentials to arbitrary code by design. And it's not just malicious servers. Even with a completely legitimate, well-intentioned MCP server, those credentials are sitting on an endpoint in a plaintext file, accessible to any process running with the same user's privileges. If that laptop gets compromised through any other vector, a phishing email, a browser exploit, whatever, the MCP credentials are just sitting there waiting. This is actually how agents get provisioned across the board, not just MCP. Most frameworks and tools involve handing the agent static credentials at configuration time. Long-lived API keys, personal access tokens, service account credentials, all handed over at setup and held for as long as the agent runs. And honestly, think about the contrast. For human access, we've spent years building just-in-time provisioning, session-based authentication, MFA, conditional access policies. For agents, we've basically gone back to, here's a password, keep it forever. It's like we forgot everything we learned about credential hygiene the moment agents enter the picture. To be fair, credentials scattered across developer machines is not new. Most IT and DevOps machines already have secrets in config files and CLI tools and environment variables. That's been true for years. What agents do is they make it worse. Because now, those credentials aren't just sitting there waiting to be stolen. They're actively being consumed by an autonomous software that decides on its own what to do with them. And later on, we'll talk about why the obvious fix, just rotate the credentials, make them short-lived, scope them tightly, sounds great on a slide, but doesn't actually solve the problem. Spoiler alert, the agent doesn't care how fresh the token is if it's already been told what to do with it. But we'll get there. The industry knows this is a problem. The MCP specification itself has been evolving. The November 2025 spec update added OAuth 2.1 support and authorization discovery, which is a real step toward replacing those plaintext files with proper auth flows. But today, the vast majority of real-world agent deployments still rely on static credentials and config files. That's just where things are right now. And that's why the next step we need to talk about, prompt injection, is so much worse than it would otherwise be. Because when an agent gets manipulated at runtime, and we'll get into exactly how that works next, it's these static, broadly scoped, long-lived credentials that determine how much damage is possible.